chapter. It's probably the toughest stuff of the chapter, but if you're paying attention and you can remember a little bit of what we did from chapter 6, then you should be okay. So we're going to use properties of logarithms. And what we have to remember is whatever we're finding the inverse of has to follow the exact same rules as what we were working with in the first place. And so when we talk about how the properties of logarithms are used as inverses for exponential growth and exponential decay, exponential stuff obviously is involved. So we have to remember things like if they gave us x squared times x to the third. What were we supposed to do with those two exponents? We were supposed to add. To multiply similar bases, we add the exponents. So logarithms have to do that as well. If we want to multiply a couple logarithm numbers together, then we have to add instead. And then we had division. So what did we have to do with those powers? We did have to subtract. Had to do that. And recently, we've had to talk about this situation. If we had x squared to the fourth power, what do we do with those two? That's where we multiply. Yeah, we used that in yesterday's when we were equating the bases. So logarithms have to do those exact same things. If they don't, then they can't be an inverse. They have to do this process and undo this process. This getting ready, I think I'm going to save that one for tomorrow. It's a good one, but I'm going to save it for tomorrow. So here's our essential understanding. Logarithms and exponents have corresponding properties. They have to. They have to follow those same properties. So down here in this box that says take note, this is where we're getting the properties of logarithms. And just like the problems that we went through before, we see, well, if logarithms tell us to multiply, we have to change that to add because they have to follow the same rules as exponents. And if logarithms tell us to divide, we have to change that to subtraction. If logarithms say, hey, raise this to a power, well, we have to multiply. And this one looks different because what happens is we bring the n out in front to multiply it. So what we have to do is, like I said, if you already remember everything about chapter 6, then you're okay. But we have to remember that for logarithms, when they say multiply, we have to add. And if they say divide, what are we going to do? And if they say to raise something to a power, we will multiply. Now, this process is going to work in two different directions depending on what it is they want us to do. So, if they give us a problem that says expand, I'm going to write that over here. And you should be writing all this down, everybody. This is going to help you out big time with these logarithms. If they say expand, we're going to use this list top down. Anything that we see that's multiplication, we're going to change it to addition. Anything that's division, we're going to change to subtraction. Anything that says raise it to a power, we're going to make that multiplication. So when we expand, we use it top down. But they're also going to say either write as a single logarithm or the proper word for that is condense. This book likes to say write as a single logarithm a whole lot, but almost every other book calls it condensing. So condensing goes bottom up. Get attendance changed before we get too far, and it looks like you've been gone the whole hour. All right. So it follows the same rules that we have for exponents back in chapter 6. And remember, chapter 6 was the chapter that most people will say, that was the toughest chapter we ever covered in Algebra 2. But we're just looking at pieces of it here as we try to figure out how do you undo these unknown powers with logarithms. And usually, when you look up here, it makes sense. Multiply becomes add, divide is subtraction. Take this power, instead of raising it to a power, bring it in front to multiply. But then after a while, you start thinking, wait a second. They only had one logarithm base b here, and now there's two of them. That's because they're expanding. When you expand, you're taking a logarithm and you're breaking apart into its pieces. So multiplication becomes addition, and you write that logarithm piece down twice. Same thing with division. Division becomes subtraction, so we have to separate them and write that logarithm base b piece down there twice. And with this one, again, it's different because we're just bringing that number out in front. Now, if left to right is expand, well, then eventually we're going to have to condense. So they're going to give us the right side of these, and we have to work it back to the left side. So condensing and getting a single logarithm are exactly the same thing. We only want this really basic one logarithm statement when we condense. So we get right into it today. This is another one of those where, depending on how you guys feel about this and the questions you ask, this is not going to take too long today. But I want to make sure that everybody remembers the rules follow what we do for exponents. So this one says, what is each expression written as a single logarithm? Now, that's condense. And the first thing to watch out for when it says condense or write as a single logarithm is, do they have the same base? Because the only way we can put them together is if they have the same base. John, put the phone away. So the first thing I looked at in A was, oh, good, they're both logarithm base 4. Excellent. So I can put them together. And then I try to think, subtraction in logarithm language. What does subtraction mean? It does mean division. So what I do is write 1 logarithm base 4. And then I use the division, and I realize, well, I can do that division. We can all do that division. That's going to be 16. Because our goal is, if we can, to write this as a single number, if it's possible. Sometimes it's not, because you'll have variables in it. Now, I want you to imagine that you can write equals x over here, snail shell it, and see if you can tell me what it is. It's a 2. This says 2. 4 to the something is 16. That something is 2. So we really condensed that one. We even got rid of the logarithm piece right there. All right, so condensing. That one only had subtraction. This one has 2 pieces to it. Now, the first thing I'm looking for again is, are they both the same base? Are they? Second thing I'm noticing is that 6 shouldn't be out in front like that. How did that 6 get there? What makes it multiplication? What does that? A power. So it's got to go back up. This has to go back up just to the x, because the 6 is only in front of the x term. I don't like that 5 there either. Where does that have to go? Yep, to the y. So you put those powers back up, because raising to a power becomes multiplication. Okay, well now I have to deal with is addition. What's addition in logarithm language? Multiplication. So we're going to put them together. X to the 6th, y to the 5th, and I'd probably just put a set of parentheses around those two. So because these are variables, we can't get a number answer for anything. But we can certainly condense it and put them together. So when I made that chart before, remember I was talking about the directions. If we have to condense anything that was raised to a power, it's going to look like multiplication. And you're not going to see that because I'm in front of it. It's going to look like multiplying. We have to put it back as a power. Anything that's subtraction, we change to division, and anything that was addition, we change back to multiplication. Again, has to work both ways. Condense and then expand. All right, so these are the got-its, and I've already had you help me, but more help would be great. What are you looking for in 1A? Same base. Do they have it? All right. Do we need to put any numbers back up? No multiplication this time, right? So what do? Multiply. Addition is multiplication in logarithm language. And you might do that in one step. I'm just making sure that I've got a step here to show somebody that's looking at the notes later, you know. So this will be logarithm base 4 of 15x squared. Now here's the only thing I'd check for. Is there anything I can do with that? It's got a variable, so done. Can't do anything with that piece. All right, let's look at B. First thing to check for. Looking good? Both fours? Okay. Any numbers in the front to get rid of? There is this time. But it's only for this term because they're separated by subtraction. This 2 has to go back up here. Oh, let me just put it up there and not skip a step. And then you'd say to yourself, well, I know what 6 squared is. That's 36. Now we have some subtraction taking place. What's subtraction in logarithm language? Division. Wait a second. I think we know that one. It is 1. They're inverses of each other. These bases are exactly the same. There it is. So that's condensing, putting the powers back up, checking to see. Addition, subtraction, how do I change that? And condensing is the same thing as write as a single logarithm. Now we have to go backwards. Now we're going to take one logarithm statement and we're going to change it into things that involve sums, differences. Maybe we have a product because we have to move a number that's a power out in front of a term. So we can expand that single logarithm to involve the sum or difference of 2 or more logarithms. We want to break it up as much as we possibly can. But don't lose sight of this. If at some point we have a logarithm that just has numbers, we really want to do the best that we can to get that down to an actual number if it's possible. So this is, again, kind of power chart territory. If you're not remembering all of your numbers being raised to a power, having that power chart out for this assignment will probably come in handy. Alrighty, it says, what is each logarithm expanded? Well, let's see. Step 1 is change any multiplication into addition. Oh, well, the 4 and the x are being multiplied up here. So I'll have to do log of 4 plus log of x. And while I'm at it, they're dividing by y. What's division in logarithm language? Now, the only one I could possibly do anything with would be the one that just has the numbers in it. So I think about log. What's the base when it just says log? 10. 10 to the something gives me 4. Is that something nice that's going to show up on my power chart? So it's done. Because if it's not nice, we leave it. We only want things simplified in these forms. Alrighty, B looks like a good problem. Well, there's no multiplication there, but there is division. Division is what in log language? Okay, so log base 9 of x to the 4th minus log base 9 of 729. Oh, wait a second. There's a power in this one. What do you do when you raise to a power in logarithm language? Put it in the front to multiply. Now, just in front of the term that needs it. It only goes for the x, so it's just this term that's going to get that 4. Now, I'm thinking we might not be done. So if you have a power chart, because this is a bigger number we haven't seen for a little while. In fact, I'll get the power charts out in case anybody realizes they don't have theirs. Oh, thank you. Here I was thinking about grabbing the power charts, and I put the 4 back up there as a power. Get that off. There. Because I'm not sure we're going to remember this one. The one with the number, remember we tried to figure it out, right? 9 to the something is 729. Do we know that something? The third. And there it is. So again, power charts will come in handy. So when we get to the homework, I'll check with you and see if you still have your power chart as you go through those. Again, it's just the numbers that we stop and think, hey, can I simplify this? Can I do anything to this? Now, the reason I bring that up, we've got a little extra simplifying to do in 2A. 250 is a pretty special number, right? 37, not so special. But 250 has a lot going on. So, let's start with, what should we do? Oh, you don't have these two? Rats! Okay, so that means we're taking off something that's a little bit tougher. All right, so what's your A? Over what, I'm sorry? 31? Okay. Well, that takes some of the fun out of that problem. Because 250 is a cool number. Do you notice that 250 is 2 times 125? Yeah. And 125 shows up on our power chart. That's why we took this one off, is because people miss that. So we thought, well, we'll just make this one a little easier. All right, so let's go with the easier one. First things first, I see some major division here. What's division? I don't like my 3. All right, took care of the big one, which was the division. Oh, well, 48 is times x squared. What's multiplication in logarithm language? I don't think we're done with that middle one. So do they all get a 2 in the front? Just the middle one. That's the only one that has the x. Unless, snail shell, see if anything works out. 3 to the something is 48. Not something nice. 3 to the something is 31. We're done. Like I said, the other one was a little more fun because we ended up with some numbers that we could separate, but it is a little more difficult, so we must have decided to take that off at some point. You know what? Probably last year with the spring, as it was, being distance learning. Oh, B looks like a fun little problem. Smaller number, but fun little problem. So what do you see? Yeah, multiplication. What do we change that to? What's next? Just the x term, yep. Done. Good. You stop and check the number and you say, wait a second, if I snail shell this, I think I know this one. 3 to the something is 9. Hey, that's 2. Now do we have it all? Nothing else we can do with the x over there, the variables. So, as I told you earlier, short lesson today. And that's because I want to be able to wander around and help you out if you get stuck on any of these. But the biggies are knowing that multiplying in logarithm language is what? Addition. Division in logarithm language is subtraction. Raising it to a power becomes, and being able to use those back and forth for condense and expand. Oh, one more. There we go. So again, everybody working today, in case you get to one that just has you hornswoggled, then I'll help you out. Old word for confused. Hornswoggled. Renaissance times.